guys, Mrs. Brummel here. We are going to be moving into proving triangles are congruent. Before we get to the proof part though, we just want to make sure you guys are aware that actually we don't have to use the definition of congruent triangles to prove triangles are congruent. So we learned that triangles are congruent if all three pairs of corresponding angles are congruent and all three pairs of corresponding sides are congruent. That's a lot of things to prove. If I have to show 6 things are congruent, that's really difficult. And so actually for triangles, we have a number of, I like to call them shortcuts, that allow us to show that triangles are congruent without having to show all 6 sides. So the first one is SSS. So the S stands for side. So this is side, side, side. Okay? So what that means is here we can see these markings. I'm going to darken them in a little bit. Okay, so here I have this side is congruent to this side is congruent to this side. If I were to pull these two triangles apart, this side would be the same in triangle ABC as it is in ADC. So these two triangles are congruent because they have 3 congruent sides. So if two triangles have 3 corresponding congruent sides, then the triangles are congruent. So for this particular one, I could say like ADC, here's my congruency statement, triangle ADC is congruent, so I want to go in the same order. So A matches up with C, and I went from A to D, so I went along the 2 tick mark side, so I got to go from C to B along that 2 tick mark side, so C triangle, CBA. And my reason, I would say by side, side, side. Okay, so they're congruent by this shortcut because they have 3 congruent sides. Okay, I'm actually going to kind of jump to here and kind of come back to this. So another shortcut we have is if we have side, angle, side. So the angle, so I'm going to write that side, angle, side. So the angle has to be right between the 2 sides I know are congruent. We call that the included angle. So the included angle is, I'm going to say angle, I'm going to even put it kind of in, or I guess that should go here, angle, I'm going to say like sandwiched between 2 consecutive, that means like one after the other, sides. Okay, so for example, all right, this would be an included angle when I have these 2 sides I'm working with. Okay, so in this guy, again, if I were to pull these 2 triangles apart, this side would be the same in the top triangle as it is in the bottom triangle. I have these markings already, and I have these angles marked as congruent. So I have side, angle, side. This angle is sandwiched between these 2 sides. I have the same thing in the bottom triangle. So if 2 triangles have 2 congruent corresponding sides and a congruent included angle, then the triangles are congruent. So again, I can use a congruency statement. So I'm going to name that top one, I'll call it triangle ABC. Is congruent to, this would be DBC if I go in that same order, by side, angle, side. Okay, included side. So in this one, if I'm talking about these 2 angles, this side would be the included side. It's sandwiched between the 2 angles I'm looking at. Okay, so side, sandwiched between two angles. Okay? All right, so we have angle, side, angle. Okay, so I have two angles I know are congruent in this included side. So I know this angle is congruent to A, this angle is congruent to C. The side between those two angles is congruent to each other. So this is another shortcut that if, or I should say, if, we'll go the same route. If two triangles have two pairs of congruent corresponding angles and a congruent included side, then the triangles are congruent. Okay, so for this congruency statement, I could again name it triangle ABC is congruent to, this would be DEF by angle, side, angle. All right. Next, we have angle, angle, side. So the difference between this one and this one is the side is included. So the side's between the two angles that we're talking about. In this one, the side is not between the two angles we're talking about. Okay, and this is another shortcut that works. So if two triangles have two pairs of congruent corresponding corresponding angles and a congruent pair of corresponding sides, then the triangles are congruent. All right. Okay, so for this one, we can say triangle GHJ is congruent to G, so G matches with K, K to L to M, by, this one is angle, angle, side. All right, the last one. So all of the other ones are composed of A's and S's, angles and sides. This last one is hypotenuse-leg, that's what that stands for. Hypotenuse-leg theorem. So this one only works for right triangles, but if I have a right triangle and I have a congruent hypotenuse and one congruent leg, that's enough to say the triangles are congruent. So if two right triangles, so again, that's important, two right triangles, have pair of congruent legs and a congruent hypotenuse, then the triangles are congruent. Okay, and so again, I can call that one, we'll call this one BCA. Is congruent to, so I started with B, I went along the one tick mark, so it'd be E to F to D. And this one would be by the HL theorem. Okay, so those are all our shortcuts. Don't worry, we're going to get a lot of practice with identifying those. This last part of the video, guys, is just some helpful review. These are some other properties that come into play a lot. Something called the reflexive property. I actually already kind of showed it on the other side, but the reflexive property is saying something is congruent to itself. So this guy, I can actually pull apart those two triangles, right? And AB is the same in both triangles, right? This side is congruent to itself. So this is what we call a shared side. And that is the reflexive property. So I can always say something like AB is congruent to itself. That is the reflexive property. Now I also, sorry, these letters are very small. I'm going to make them bigger. A, B, this is a Q, this is a P. So same thing, I can pull these two triangles apart. So I've got kind of this look here. Sorry, my drawing isn't awesome, but so this guy, so I have A, B, Q, P, and then I pull this apart. This is really Q and P as well. So this is congruent to this. So I would say something like PQ is the same as QP. Notice this one I do switch the order because this is the obtuse angle in this picture. So I would say PQ is congruent to QP. And that is also because of that reflexive property anytime I have a shared side. So this is the shared side right there, okay? All right, and don't forget we also, anytime I have an X, I have intersecting lines, we get vertical angles, and vertical angles are always congruent. So in this one I would say like angle LNM, L and O match up together, so I would list O first, and I would say these are congruent by the vertical angles. So I would go ONP by vertical angles theorem. All right, we also have, when I have parallel lines cut by a transversal, we have these different angle pairs that show up. So again, I'm going to make these letters bigger, A, B, C, D, and then we have these parallel markings on here. So we aren't going to see this picture hardly ever in this unit, but we can still use the same angle pairs when I have something like this. So this is a parallel line to this one, and this is like a transversal. So when that happens, I get alternate interior angles there and there. So in this one, alternate interior angles would be like angle BAC is congruent to DCA. Okay? And so that's going to be important to remember, okay? So these are just some other angle pairs. This one is going to show up the most for us in our triangle proofs. So that's one I want you guys to really recall, but it's always a good review to recognize these. I'm just going to name a couple linear pairs. So like angle 1 and angle 2, remember linear pairs adds 180. Corresponding angles would be like 2 and 6. Alternate interior from this picture would be like 3 and 6. Alternate exterior 2 and 7. Same side interior would be like 3 and 5. Oh, 3 and 5. And then vertical, we did a vertical up above, but vertical here would be like 6 and 7. So just as a review, those angle pairs will still show up a little bit, but especially alternate interior and vertical angles will be the most common. All right, guys, thanks for watching.